If you've been following the massive explosion of AI in education lately, you probably already know the holy grail, right? We're all chasing this dream of a personalized, persistent tutor, something that grows with you over the years, constantly adapting its explanations to exactly what you need. But honestly, the way the tech industry is trying to build that dream right now is fundamentally flawed. In this explainer, we're diving into a revolutionary new product called OLMS, which stands for the Oppositional Learning Management System. We're going to break down exactly what this product is, how it works under the hood, what makes its architecture so incredibly powerful, and why it is, quite frankly, light years ahead of the conversational AI chatbots that we're currently treating as teachers.
So here is the core problem. What if the AI tutors we're building today are entirely the wrong shape? Because right now they just talk, they don't actually teach. When you interact with most AI education tools today, you're essentially just interacting with a conversational surface. I mean, sure, they're super polite, and they can paraphrase a Wikipedia article with this great friendly persona, but mimicking the form of a teacher is absolutely not the same thing as executing a long-term instructional strategy. The industry has completely confused language generation with pedagogical control. If a student gets an answer right, the chatbot just moves on. If they get it wrong, it just repeats the exact same question in a slightly friendlier tone. It's completely blind to long-term memory, prerequisite knowledge, and actual skill transfer.
And this brings us to a massive distinction, producing the next sentence versus choosing the next experience. Rendering is just how a system expresses itself, the wording, the tone, the simulation of empathy. But selection? Selection is deciding what the learner should encounter next, why they need to encounter it right now, at what difficulty level, and with what expected effect 3 weeks from now. Current systems let the language model do both of these things at once, and that leads to incredibly shallow variation, endless drilling on the exact same weak point, and a total failure to recognize when a student is just missing a foundational prerequisite.
It really all boils down to this central thesis from the white paper. A language model can produce the next sentence. A teacher must choose the next experience. The core intelligence of a true tutor isn't its vocabulary. It's its ability to make sequential decisions under uncertainty to maximize the student's long-term understanding. Think about it. If you swap out the language model, whether that's the voice or the text renderer, the actual educational strategy underneath shouldn't change one bit.
Enter OLMS, the Oppositional Learning Management System. Instead of relying on some black box AI to magically guess your mental state based on a few chat tokens, OLMS operates on a strict auditable policy. It maps a student's demonstrated abilities, what we call mastery frontiers, against a massive shared map of human knowledge. It completely 100% separates the curriculum, the grading, and the teaching logic away from the conversational interface.
Let's open up the hood and look at how this works. Section 1. The Epistemic Atlas Engine.
To teach effectively, you have to know how concepts relate to one another, right? OLMS doesn't just use a simple list of subjects, it uses a universal epistemic substrate. This is a massive, versioned representation of knowledge, skills, facts, misconceptions, and procedures. But the absolute genius of OLMS is that it recognizes that not all knowledge is shaped the same way. So it uses mixed geometry knowledge graphs. What does that mean? Well, if you're learning biological taxonomies, the knowledge expands exponentially, so OLMS maps it using hyperbolic charts. If you're learning physical quantities, it uses flat Euclidean charts. And if you're learning something like music theory, where pitch classes repeat in octaves, it actually maps the knowledge on circular topologies, like toroidal or orbifold charts, basically the shape of a donut. It uses the exact right math for the specific subject, so the underlying teacher policy can calculate the perfect path from what you currently know to what you need to learn next.
This naturally brings us to Section 2, Tracking True Mastery Frontiers.
Remember how current AI tries to build a psychological profile of you based on your chat history? Yeah, OLMS doesn't claim to know your soul. It tracks cold, hard evidence on that epistemic atlas we just looked at. It projects a sparse overlay on top of the knowledge graph to map your exact boundaries across 4 distinct layers. First is the credential frontier. This is what your past transcripts say you should know. It's just a hypothesis. Second is the demonstrated frontier, what you've actually proven you can do in front of the system. Third is the durable frontier, what you can still remember and do weeks later without any hints. And finally, the transfer frontier. Can you take a concept you learned in physics and apply it to a completely novel problem in economics? Tracking these layers is absolutely crucial because knowing a fact for 5 minutes is very, very different from mastering a concept for a lifetime.
And knowing a concept isn't just a simple yes or no. You might be able to remember a definition, sure, but can you apply it? Can you evaluate a flaw in it? Can you create something brand new with it? OLMS applies the revised Bloom's taxonomy, which is a classic educational framework ranking levels of thinking, as an orthogonal capability grid over the knowledge map. So the system isn't just deciding to teach photosynthesis today, it's explicitly choosing to test your ability to analyze the procedural steps of photosynthesis under completely novel conditions. This level of granular, intentional teaching is literally what separates a real learning management system from a basic chat wrapper.
Next up, let's look at Section 3, the oppositional learning loop.
A correct-looking answer from a student doesn't necessarily mean they've mastered the material. They could be guessing, or they might just be leaning way too heavily on the AI's helpful hints. To build that true mastery frontier, OLMS uses an oppositional loop. Now, oppositional here doesn't mean adversarial or mean, it just means rigorous. It treats every single answer as a claim that must be verified. Here are the 5 steps. First, it elicits a targeted performance. Then, it challenges your reasoning to make sure you aren't just reciting a script. Third, it diagnoses not just if you are right or wrong, but the specific quality of your reasoning and any hidden misconceptions. Fourth, it records this evidence permanently. And finally, it replans the entire instructional sequence based on this brand new, verified evidence.
To pull this off, the system architecture is incredibly rigorous. Standard AI tutors burn all their processing power just rendering text in real time. OLMS completely flips the script. Look at this upstream versus downstream token flow. It spends upstream tokens ahead of you. Before you even see a question, the system is searching your mastery frontier, predicting outcomes, and selecting the perfect pedagogical move. It's anticipatory compute. Then you respond. That response is the narrow waist of the system. After you answer, OLMS spends downstream tokens. It's not just grading you, it's running evidentiary compute, asynchronous processes to extract evidence, resolve contradictions, and update your durable frontier ledger.
Which leads us to our final point, Section 4, why OLMS is better. From a product and market perspective, why is OLMS the ultimate game changer for EdTech? Here's the competitive advantage: provider independence. OLMS decouples your curriculum and the grading from any single AI provider. No single tech giant owns the definition of truth here. Because the policy and the knowledge graph are separate from the language models, you get model plurality and context-fit routing. You might use a super-fast, low-latency model for the live conversation, but route a complex essay to a highly analytical, deep reasoning model from a completely different company to update the frontier. This saves computing costs while ensuring rigorous independence. Above all, OLMS optimizes for your delayed retention and actual growth, not just trying to make the current 5-minute interaction feel helpful. The promise of the AI tutor is absolutely incredible. But a chatbot with a long memory is not a teacher. A true teacher requires insight into what you've proven, the foresight to know exactly where you need to go, and a rigorous strategy to get you there. So, the next time you're looking at a shiny new educational AI product, I want you to ask yourself, do you want an AI that claims to just know the learner, or an evidence-driven teacher that actually knows where the evidence ends?